dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 225. In this lecture, we will try to understand distance of a point from a plane. Just see, let me assume this is my plane pi. This is my plane pi. Also, let me assume this plane, for simplicity, this plane, let me assume this plane pi passes through the origin. We know the equation of the plane which passes through the origin, that is W transpose x equal 0. I already discussed this equation many times in my previous lectures. Just let me say this one is normal at the origin. Let me assume this one is the origin and your W is origin. Now, my intention is we have to find perpendicular distance or shortest distance of this particular point P. Let me assume to this plane. Shortest distance means I must say it is a perpendicular distance. Now, what is this? This one is my pi which passes through the origin, that is W transpose x equal to 0. Now, we need this distance, this from here to here. I need this distance, isn't it? How can I find this distance? Just see this one. Let me assume this distance is d. This distance is d. This is perpendicular distance of this point P. Even if you want, you can assume this one is O, this one is Q, you can assume. It is simply perpendicular to the plane. I need this distance. How can I find this distance? Just say, as I told you, this W is normal. Let me redraw it again. Let me say like this. This is as usual O. This is my pi, whose equation is W transpose x equal 0. I need this distance d. Let me say this is Q, this is O. Now W is, as I told you, this W is normal. Now I need this particular distance d. How can I write this one? It is simple. How can I find this d? It is simple and straightforward. As it is normal, let me say this is like this. Now, let theta be an angle. It's an angle, be an angle between W and P. Otherwise, I can say, let me say OP. Otherwise, this angle, let me say this angle is theta. In that case, what is this angle? This is 90 minus theta, as it is normal, isn't it? It is 90 minus theta. This one is also perpendicular. Now, by using this, how can I write what is my sine theta? Sine of 90 minus theta. What is sine theta formula? My sine theta is opposite side. What is opposite side here? D by, let me say this is OP. This length is, let me assume this length is norm P. Therefore, how can I write what is the formula for sine theta? Sine theta equal to opposite side by, I can say hypotenuse. Hypotenuse means that is length of this particular OP, isn't it? Length of this vector OP. I can write this one as, if I cross multiply this, I can write it as d equal to norm P. Norm P means length of that vector, norm P, into sine 90 minus theta, isn't it? Therefore, we know from elementary class trigonometry, our 10th class elementary class trigonometry, we know that sine 90 minus theta is cos theta. Let it be equation 1. Now, we also know that what is dot product. Let me write dot product here. What is my dot product definition? W dot P equal to, we already defined this dot product in my previous lectures, which is equal to norm W into norm P into angle between the W and P, isn't it? That is, I think I can say it's cos theta. That's definition. I can write W dot P equal to, in the place of norm P into cos theta, in the place of norm P into cos theta, I can write it as norm W into D. I can write. How do you know? This is from 1, isn't it? Is it not from 1? Yes, it's from 1. Therefore, what is my D? From this, how can I calculate D? My D is equal to W dot P by norm W, isn't it? This is it not perpendicular distance D? We are interested in finding this distance D, this perpendicular distance D from this point P to this plane pi. It is simple and straightforward derivation. I requested you to derive this simple derivation in my previous lectures. Anyway, this is simple proof. Just go through it. This is very useful in finding projections, in understanding principal component analysis, all those things. Thank you very much.